Okay, so welcome to the May 20th Carpenter Working Group meeting. Thank you all for coming. Getting right into project updates. A quick update for the AWS cloud provider implementation. We released patch releases last Friday for versions 31 through 36, and do recommend if you are on any of those minor versions to update to the latest patch release. This addresses a bug where we can mistakenly identify Ami drift, and this can cause nodes to roll unintentionally. They roll to the same Ami. Yeah, it, I don't expect there to be any issues with the roll per se, but it just causes unnecessary node churn. So yeah, if you're on any of those affected versions, we do recommend you upgrade to the latest patch release. So that is it for the AWS provider. Moving on to Cappy.
Yeah, we had a really good design session last week with kind of the upstream community. We're working through some issues where we're kind of going back and forth about how our back end design would look. And by back end, I mean, you know, the way I view the cluster API provider in kind of contrast to the other providers is that in the cluster API provider, the cluster itself, or the management cluster where the cluster API pieces live, that is the cloud provider, right? So that's like our source of truth. There is no metadata service that we can go to, any of that stuff. So we had to make some decisions around how does that interface look for Carpenter, and I think we've made some decisions at least for the short term. So I'm pushing ahead just to try and get us to like a minimum viable, product, I guess, or project in this case, where we could start like testing it out and playing with it. So that's what we're trying to work towards at the moment. It may not be the ultimate or kind of the end approach we take, but we want to, as a community, we'd like to get to a point where we could just start manipulating Carpenter and seeing how it works with cluster APIs. So that's kind of where we're at the moment. I'm hopeful that over the next month we'll make a lot of progress, kind of getting the cloud provider interface working, and then hopefully seeing it do something basically. But I've got a follow-up question in the community questions part to kind of help further that. So anyways, yeah, that's kind of where our status is at the moment.
Awesome. Do we want to get right into that question you had in the community questions then?
Yeah, I mean, yeah, if there's no other business in there. So basically, I'm doing a lot of implementation around the node claim object at this point, and I'm wondering, kind of from the experts, what is the minimum amount of information that I can operate on in the node claims? Like I realize, capacity, we need to have the capacity information there because it needs to know what sizes are. But like if I fake on things like taints and requirements and stuff like that, like can I leave those empty for now? And then kind of the follow-up is I noticed in one of the statuses, I think for the node claim, there's a comment about needing to have all the well-known labels in there, even if you're not using them. And I've got a little follow-up to do there, but like, I'm just wondering, like, if I want to fake this whole thing out, can I just give like empty blocks back, or do I need to fill them in and say like, yeah, don't worry about these things? I'm kind of curious, where could I draw the line here for like the minimum amount of work necessary to get it working?
So I think there's within like our cluster state, we like kind of keep track of like the node claim and then the node for like different pieces of information, like to get a whole holistic view of what the node looks like. Some specific things like the node claim disruption controller. Those well-known labels are how we kind of check node pool requirements on the node claim and check compatibility there. So we don't actually, I think if you don't have those labels on the node claim, then we won't be able to figure out what like is a drifted node claim. And so another example is like if someone actually changes the labels on their nodes, it won't change what we think about the node claim until they change about the node claim labels. So like node claims are like kind of a host for all Carpenter needed information, whereas like the node can actually change a little bit of details itself, and we won't actually act on it.
Okay, so let me just repeat that back to make sure that I'm understanding correctly. So like if we don't put things into those like requirements and whatnot, then Carpenter won't know about it, and so it won't necessarily care about those labels on the nodes. Is that kind of how it works, or?
So you're wondering if it's like if you omit the information, will it just treat it as like compatible?
Well, right. Like, so for example, like one of the problems that we're trying to solve in cluster API right now, and this is just a problem amongst many, like the zone information, right? When when I tell cluster API to increase the number of replicas on like a scalable resource type, like I'm telling it, make me another one of these machines. I don't necessarily know at that point what the zone label will be on the node that's created. So I'm wondering, like, can I just leave that out of like the node claim so that Karpenter would only know the zone by looking at the node? Or is that going to affect Karpenter's ability to, like, predictively schedule nodes or something like that?
I need to dive in a little bit more. I need to think about because we always create the node claim, but the node claim has like a set of options that we say are allowed, and then once we get like returned, yeah, you've made the instance, then we fill in some data after. I need to figure out what exactly we need to have on creation. I think zone might be required. Depending.
Zone is actually set by the provider after the creation because sometimes kind of deciding on which zone an instance is going to go to is done, during the creation of the instance. So I think both providers, AWS and Azure, right now fill in the zone after creating the instance.
Okay.
One more thing that may be helpful to clarify, I saw you asking the question about like having to fill in all of the labels, right? All of the well-known labels. The question on the Slack was in a slightly different context. It was about the instance offerings.
Right.
And that's a little bit different from the node claim itself, right? On the offerings, one has to kind of have the representation for every label, like have a requirement instance for every well-known label. That's not quite the fact as Nick referred to for the node claim itself.
Okay. And then could we leave the offerings off altogether? Like if we don't know it, can we just leave it empty?
Well, those are two different contexts, right? And maybe Nick, maybe you can talk about this, but like you have to have a set of offerings for Karpenter Core to be able to choose from, right? Decide, which offerings can be used. But from the node claim perspective, yes, there is a much smaller subset of things that you can fill. I probably should mention that we also have some use cases for using just node claims. And so we discussed in the past, what would it take for somebody to use Karpenter in a slightly different way, like just creating node claim, not using the core to provision node claims, but just creating node claims manually. And we've experimented with this a little bit. So maybe that's like a different way to ask the same question. One thing that we found out that like, even though generally speaking, I think there was an agreement that, there is really nothing in Karpenter that prevents this scenario, and maybe like even informally it should be supported. There are still a couple of blockers. For example, it looks like node pool, some kind of reference of node pool would be required right now. There are a couple of small things, I believe, in core that expect this reference to be filled in. Maybe even like a fake, I don't remember what is it, a label on node claim referencing the node pool. But so far, I think we run into a couple of issues trying to start with provisioning node claim, without node pools. At least one of those is in our provider actually, so it maybe not, doesn't extend to other providers, not a generic limitation on Karpenter, but maybe worth mentioning if you're talking about what's the minimal node claim that you can work with.
Yeah. No, that's good information. Thank you, Alex. Yeah, I realize some of this is kind of experimental for us too, because we're trying to figure out like there's some information we don't know in cluster API when we're doing things like creating nodes or trying to provide the instance types and whatnot. So I'm trying to figure out like kind of how much can I give, what's the minimum amount I can give just to start seeing this working. And then I can go back to the cluster API community and say, okay, how do we provide this other information? So yeah, this is a good start. I guess the other sorry, go ahead.
Yeah, sorry. I was gonna say one opportunity is if you wanted to like just try it out yourself in like the clock provider. You could always just like use the clock provider and see what happens when you try and like modify the create node object and then omit specific labels and see where Karpenter might break. That's one way you could, I guess, like try and
Yeah, that's a great suggestion.
pinpoint every single type of label that does or doesn't need to be required at different times.
Right. That gives me a nice way to test it locally too. I can just kind of run it back and forth. Okay,
Yeah.
cool. So I guess following on the same lines, in Cluster API, the way we're approaching this now, when we get a call on the provider interface to create, a new node from a node claim, we won't know the provider ID right away, because like what we're doing is we're going to take that node claim and we're going to figure out which machine deployment we want to increase replicas on, and then we're going to increase a replica. And then the cluster API mechanisms will make the new machine. So what I'm wondering is, assuming I can figure out how to synchronize this, is it okay to return from the create call of the node claim and then later reconcile the node claim to add the provider ID? Like, can that be done that way, or does the provider ID need to be there when the node claim is returned from that create call?
I think there are some assumptions we've taken in cluster state that returning from the create call, you'd have a provider ID. So you might have something that
It's no, so Jonathan would, unless something has changed since we did the machine work, this is the whole reason we created the node claim object, was to allow the provider ID to be async.
Okay, cool.
So within our provider, it's like 1 to 2 seconds before we can get the provider ID. But the idea being that like node claim allows you to have some handle that the provider ID can hydrate into. I don't know if there's assumptions in the code base that now rely on that to be there much faster, but there's no reason why it couldn't take an hour or a week to do that. It should just your node claim should just sit there.
Okay.
I don't know, Nick,
Yeah.
if that would like cause provisioning to freeze for some reason while we wait for those provider IDs to hydrate. So there's maybe some internal stuff we should track. Maybe even worth like writing an intake test that like slows that thing down to a couple minutes just to make sure that everything's like working. But yeah, by design, it's meant to be async to meet this exact requirement.
Okay. So oh, sorry, go ahead, Alex.
Yeah, I just wanted to follow up with like similar question because we have slightly different variation of kind of similar ask. Is there a way to communicate failure to provision async? Because like in our case, the Azure APIs are like inherently, I mean, there is a concept of long running operation, right? Where we kick off provisioning and then, we poll for the result. And we'd like not to have to wait in the create call until we know for sure, the instance has been provisioned successfully or not. So I'm wondering if the same mechanisms that you described could potentially be used to communicate, failure to provision sometime later.
Yeah, we basically, yeah, like what Omiko is saying is that we have some status on the node claim. So what I was thinking earlier was like there's like the create a node claim, and then when you get the create node claim, then our controller will try and use the cloud provider create. And so once that succeeds, then you get the provider ID back, is what I was thinking. But afterwards, then there's like 2 other stages of like understanding how far along it is and connecting to the cluster, which is registration and initialization. Right now, if you create an instance, at least I think in the AWS, I'm not sure if it's the same in Microsoft, but we'll keep trying to create the instance. And if it doesn't register after 15 minutes, then we'll delete the node claim, and then we'll try and create another node claim. Is that what you were talking about of like wanting to have a failure? Is that like initialization timeout? Is that what you were thinking?
I think it's similar. I'm just looking for a way of returning quickly from the cloud provider create call without knowing for sure whether creation has been successful or not. And it sounds like what you're describing maybe like actually not filling in provider ID, like even if we know it, maybe a way of doing it. Though I think I was looking for something a little bit more explicit rather than detecting this failure only when the node fails to register, which I guess would work as well. I'm looking for something a little bit more explicit when at some point later we do find out that, provisioning failed. If there is a way to communicate it through the node claim, then, the actual failure.
I don't think there's anything like that right now. I think like once you hand it off, if it doesn't come on, it doesn't register, and that's the next signal, and everything in between is like a black box for Karpenter from what I can tell. But I think the registration TTL I thought is on the core and not on the individual providers. I thought that is just universal, that everyone will fail after 15 minutes if it doesn't come up and register.
Yeah, that part works, and that's not a problem. What's a little bit of a problem right now for us that we're trying to figure out is kind of the synchronous nature of the create call from the cloud provider.
Yeah.
The necessity to basically return success or failure at that point, which we're doing that right now, but we're doing it at the expense of essentially waiting, and blocking this create call for a long time. So we're looking for a way out. And sorry, I didn't sidetrack it. It just felt relevant in the context of like sync async, what it is that's required to be returned from the create call.
I think that needs to change, right? Because I think when we looked at it, it was asking for instance ID, and the call that Azure uses requires synchronous creation of the nodes before the instance ID is returned, whereas AWS is faster, but then like it doesn't necessarily wait for the instance to be completely ready. So it's like seconds instead of like a minute or two, I think, when we last looked at it. So I suspect there's something that needs to change there if you want more like asynchronous instance ID coming back. Like that, I think is not a co-path that the Karpenter does right now.
Makes sense.
You should sync with Jonathan. Pretty sure we have all these cases covered. Like we have insufficient capacity errors is one type. Like if you try to launch a node claim, but the cloud provider is out of stock, like say for Spot or something. So we do handle that case. I don't know if and Jonathan's the expert in this area of the code base, but I don't think that there's any use case here that AWS doesn't have.
I think the prompt here is that you find out right away when you make that call to AWS, but Azure is like, if you want the fast return, it's asynchronous. So maybe you won't get this information right off the bat.
And this is going to be really important for Cluster API too, because everything in Cluster API is going to be asynchronous, right? Like I'm going to be like the Cluster API provider is going to be adjusting resources in the Kubernetes cluster and then having to react to those changes. So like to kind of pop back up the stack here to what Ellis was talking about originally, it sounds like kind of the pattern that I might want to create in the Cluster API provider is also add a controller that reconciles the Cluster API resource that we're looking for, in this case, a machine, and then it can reconcile back the provider IDs and the states back to the node claims that it knows about. And I think that's what we need to do to bring this back. But if I understand what Ellis is saying, it sounds like Karpenter is, at least originally, was meant to be tolerant to the node claims being updated in asynchronous manner. So like you could create the node claim, and then action can be done in the cloud, and then we can update the node claim to say like, it succeeded or it failed, or here's the provider ID or whatever. Like, so I just want to make sure. It sounds like that's kind of the direction. If we go that direction, we're following in the best practices for Karpenter. Is that accurate?
Yes. Again, Jonathan's probably the right expert here because I'm a little bit out of date on the latest state of the code base. But unless something very significant has changed, on line 84 on that thing that I linked, if you return an insufficient capacity error, then we will delete the node claim. So that actually just tosses the node claim and allows Karpenter to recompute everything. So that's like the cloud provider failure case where you cannot fulfill the capacity. And then on the other side, like actually getting the provider ID, like that should be coming through on populate node claims details, which should be happening on each loop of the launch cycle.
The insufficient capacity, though, it's something that one would have to return from the create provider call, right? So if
Yeah.
it takes time to figure it out, it means that like create call is blocking, for the lack of a better word. And maybe that's something that we should talk briefly about, like what exactly are the consequences of the create call being, long running or taking time or blocking. I mean, I know core fires them off in parallel, but maybe, we can help us think through the consequences of this being blocking or taking a long time.
Yeah, I see what you're saying now. Yeah, that's actually kind of surprising to me that that's how we're doing it. I thought we were the create and then the discovering the provider ID was actually decoupled. We have this populate no claim details function, which I thought we were using in multiple places, but
You may be
I-
right about the provider ID. I'm not sure about like overall success or failure, especially failure, right?
yeah, I think I'm actually out of date on this one.
Yeah, it's been I need to look at that thread again. But like, yeah, essentially from I think Jonathan was looking, it's like, oh, there is some synchronicity in regard to instance ID coming back. I think it works fine in AWS because it comes back in seconds, but I think other providers doesn't work the same way, and it becomes problematic. I think for Azure, like it's almost like a minute for it to come back. So yeah, your create call just gets stuck there for a minute. I think the third was regarding like disruptions in like drift and having multiple nodes be drifted at the same time. Yeah, I can try to find a thread, but essentially from there it's like, oh, it's almost synchronous. It's because it's taking a long time to come back. So each call to create nodes becomes a minute staggered-ish. Yeah.
Yeah, so it's basically like we've taken the assumption that there's synchronous APIs, or sorry, asynchronous APIs, but some other cloud providers, their APIs are more synchronous than others. Basically what it sounds like.
So just as kind of like an action item out of this, I'm probably going to take Nick's suggestion and start messing around with the Quack provider to see if I can like, what edge cases I can find. If I end up finding anything about like, provider ID not working, if it's not supplied or anything, should I make an issue on the core Karpenter repo just to carry the discussion on there? Like, would that be considered like bug behavior, or is that something that we would want to have a discussion there? I'm just kind of thinking if I do some experimentation and kind of can find some cases where this isn't working the way that it might be best, for asynchronous behavior, is it cool to start opening issues or something to talk about it, or what would
Yeah.
the preference here be? Okay.
Yeah, I think issues would be the best way to do it so that
Yes.
you can link back to it in future community working groups.
All right, cool. So
It's
maybe
easier
what I
to
can do
not
is,
find a thread.
yeah, like if I can make like a test case or something with the Croc provider that kind of demonstrates some of this, maybe what I'll do is I'll bring that to an issue, and then we could have something meaty to kind of discuss or whatever. Okay, cool. This has been really helpful for me. Thank you, Nick and Garvin and Ellis and Alex. Great discussion.
All right, awesome. So I guess we can go ahead and move on to the next community question. Looks like we had some discussion on VM memory overhead.
Yeah. So, hi, I'm Paul. I haven't been to this meeting before, so thanks for having me. Yeah, the topic of discussion I wanted to raise here, kind of open-ended at the moment, is just thinking through options for the currently global VM memory overhead calculation. And just for like a little bit of context, it's like, so we're all on the same page, is like, what I'm thinking of is when provisioning a machine from EC2, there's sort of like the listed amount of memory you actually provision it, you get like what's reported to kubelet's going to be a little bit less than that. And so Karpenter needs to be aware of that difference for scheduling pods. Currently that flag is global. Like there's a percentage of just like, okay, what percentage of this machine are we gonna of the memory we're gonna subtract out when accounting for scheduling pods onto it. And what we've found on our end is that since we run instances in the same cluster that can range from very small to very large, it's really, really hard to get a percentage that works for everything. And so when we've picked too low in the past, Karpenter will spin up a node and then it actually cannot place the pods onto it. Or sometimes Karpenter will pick workloads to consolidate into a smaller node. And then when it spins up the new one, it realizes it can't actually put things onto it. And then on the flip side, when we set it high enough to accommodate the smaller instances, we're now forfeiting like a lot of memory from our larger instance sizes. And so I was kind of curious, you know, what palatable ideas are there for working around this problem? I may think on our end, the ideals like Karpenter just knows how much EC2 is actually going to be giving you for all these different instance types. But short of that, are there other knobs or ways of configuring Karpenter that could make it a little easier for this situation?
Yeah, so this is definitely something we've heard before. The tough thing here is that what you're saying is that the overhead memory percent is just a guess, just a heuristic that you can use to apply to all instance types. The problem is that like this also differs by like which AMI you're using as well, because the AMI is going to take up different amount of memory. And I think it's been like a year or so now, but Jonathan actually did some good work on this of like going through every instance type and seeing where our overhead memory percent calculations are off. And what he saw was that there is some instance types where it was just below and some instance types where it was above. And it's really unfortunate that at least right now that you have like this like if you have like a really large range of like small to large instance types, then you have to find some, I guess, healthy middle that has like the lesser of two evils basically, which is like either less cost optimization or like pods that can't schedule, which we think are going to schedule. And I guess in the meantime, I think that's the best we have right now. I know that there's other GitHub issue. I think there might be a GitHub issue about this. There should be at least, where I think that'd probably be something that we should, start tackling a little bit in more priority, especially if as we go to V1 where we need to be able to like actually make sure we've been packing properly.
I was chatting with EC2 about this problem recently. The other like confounding factor of this is the OS itself and the machine image, and like the kernel version, and the only way to perfectly know is to have pre-spun the instance with the exact AMI ID to know exactly how much the version of the kernel and operating all that it's using, and then you can know. And because we don't control the AMI in Karpenter, it's just not possible for us to like predict that. So we have this heuristic. Even if like you do control the AMI, it's then this like very difficult exercise of profiling and mapping, and maybe we need like a whole overhead service that's like solely responsible for listing AMI IDs and overhead. But that's kind of the only thing that we've come up with so far is like actually just profiling this and storing the data somewhere and just wiring that up the way the project, given the level of flexibility of the project, it's just quite hard right now.
I would say what we do here is we have profiled it, and I think majority of VM like hypervisor overhead for VMs has been like around 4 or 5%. So we just hard put like a 4 or 5% subtraction of memory from all instance types and just move on because it's too difficult to figure out like for instance type what the overhead is. Like, okay, we'll sacrifice that 4 or 5% and just move on because it just varies like 2 to 5 depending on like the day and like the AMI. Like it's almost impossible without like a lot of work to figure it out. So I was like, okay, we'll just carve out 5 for hypervisor and just move on.
Yeah, I think that makes sense. Certainly in terms of, it's like why this problem is hard to solve generally, which is kind of what I imagine, like if it were easy to solve, it probably would have been already. In terms of knobs that we might be able to use, I put up a total straw man PR for this, but it was something along the lines of like, could we pass in a map of instance type to the overhead that we would expect for it, or something along those lines, where it's like we know why our running on the 16x large is going to be different than the X large. Like they're doing totally different workloads. Like, could we pass in that type of information so that Karpenter has some like better sense of what's going on, or potentially using like a fixed overhead rather than percentage?
This is something that I know Garvin's really comfortable with. He's had the problems and the questions a lot. This is kind of like falls into this big issue that we've had for a while of like that you can't override specific requests or limits on per instance type. And this doesn't work necessarily with a lot of extended resources that people like to use, like huge pages or other like GPU based resources. I know that this is like conflating two specific issues, but I think this is kind of what you're talking about, like a per instance type override. And I think one of the things we tackled with and I had issues with is that like even AWS supports a huge load of instance types, and like you could say, you know, we could add some config map, we could add some CRDs. There are different ways to do this, and overall, the design work that we've done here, we first looked at it, I think like maybe 2 years ago now. There wasn't like a really good decision on how to do it. But I think there's been even a Google Doc that I kicked off that I think Bryce is also like driving as well, of like talking about extended resources support, which might be like solve that issue as well. This is the Google Doc if you're interested.
Oh, great.
Yeah, I was thinking about like per instance type overrides. There's not just your case, but also like the cost case of like the cloud provider has some special pricing contract with you, and you have some special deal or extended resources and now overhead. So there's like enough cases where I think per instance type override CRD makes a lot of sense, and it's one of the design options in a doc I've been working on in my spare time. I'm pretty busy with Karpenter GA right now. But my side project has been this design for per instance type override stuff. So I think it fits in there.
That sounds great. I'm happy to take a look at that one.
Okay, so I think unless anyone has anything else to add there, we can probably move on, see if anyone else has any other questions they want to raise. I don't see anything else left in the doc unless it's not syncing for me. All right. Well, I'm not seeing anything. I don't know if we have precedent, but maybe we can give everyone some time back and end early.
Great, thanks.
Yeah, thank you, Jason.